along would be good. It's definitely better than just listen to me rant, because I'm going to be pausing a lot to like let people catch up. So try it yourself. We'll just be doing a new R script, so you can open our studio. Can you see my file new thing that's open?
Yes.
Okay, cool. Awesome. So yeah, we're just doing an R script. We'll start up a new one. You can save it wherever. I know that Cans doesn't have Jacob to organize it today, so I'm not sure if they'll join in. We'll see.
It's all right. It's recorded. They can catch up.
Yeah.
Yeah. I'll just call it data frames. I'll give them everyone one more minute just to see if anyone shows up. Any more people show up.
We lost one.
Yeah. We gained another. So that's
Yay! It's Camilla. Hello.
Alrighty. Well, why don't we get going? Quite a bit to cover today, so I'd like to jump into it. And like I said before, if you can at least try to follow along as much as you can, or as well as you can. I really definitely think this is better if you try it yourself, rather than me just talking at you. It's better if you just try this all yourself. So the first thing we're going to do is we're just going to make a new R script, file, new file, R script. Hopefully you have our studio open and installed, but then just open up an R script, a new one. And we're going to work from this really simple R script for now. We got Tess Hill joining. Nice. So yeah, just try to open up a new R script. How's everyone doing for that? I'm going to try and monitor the chat to monitor progress. So if you're stuck anywhere, just let me know in chat before I get too far along with anything. And then we can try and troubleshoot if anything's not working. Can everyone just put in chat if it worked? Or if you're like, okay, ready to move along or whatnot. Try to make this as interactive as possible. Or better yet, if anyone has an issue with this, let me know. Cool. And I would just save it somewhere as well. So you can save it. I just saved mine as data frames, but you can just save it anywhere. We're not going to be loading any data sets, so the location isn't super important right now. But if we were loading in data sets, we want to save it probably in the same folder as our data, but we won't have any, we'll just be making up our own data as we go. So we won't have to load any data sets in. All right, so today's all about exploring data frames as well as subsetting data, which are two of I think the most glossed over things, but you end up always needing to use them because you always have weird values in your data set that you have to fix. So whenever you have a data frame, if you've got a numbers in a column and you have one NA as a character string, sometimes R will read that in wrong and it'll think that NA is a character. And because one of the things is a character and the rest are numbers, it'll automatically convert everything to a character string, which is super annoying. So we're going to talk about how we can fix things like that, or how to just get rid of certain values in the data frame. And hopefully we can get through as much as we can. This is probably going to, I think I maybe have included too much into this, but we'll see how far we go. So the first thing we're going to do again is if you're just joining in, open up your own R script so you can follow along. We're just going to make a data frame that they're suggesting in the workshop called cats. So we're going to make a new data frame called cats. We're going to assign it a value of data.frame. Oops, spell. So this is how we just start any data frame object. We could just write data frame, and then we're going to add in some vectors to fill that in, to populate it. So the first one we're going to do is we're going to talk about the cat's coat color. So we're going to go coat equals C. So the C is the vector part. So that's where we're going to be adding in a vector of values. We're just going to have 3 values. These values are going to be calico, black, and tabby. These are the coat colors of the different cats we're adding in. So it's calico, comma, black, comma, and tabby. And don't worry, this is probably likely where things go wrong. So just be careful of your parentheses, because if the one is in a wrong place, it might screw things up. So that's the first vector we're putting into this data frame. So just remember, a data frame is multiple columns with like basically different data, like the types in it. So the first one we're gonna have is like a character strings, calico, black, and tabby cat. The next one is for each of these cats, we're gonna have their weight. And I'm just stealing this again. So we're gonna make a weight vector. So this is again C for making a little vector, stands for collate if you're interested. We'll just add in numbers. Numbers we don't have to put quotations on. We just have to separate by commas, and then we're good for numbers. So that's weight. And just notice that I've put a comma and then enter to the other line, just to make it look nice. But it would still work the same if I had written it as this. It would still work the same. I just put in an enter there just to make sure that everything looks kind of neat and tidy. So we're just going to do that really quick. We'll do a weight one. And then we'll add in one more. We'll add a comma, enter, and we're going to add one called likes string. So this like string vector is going to be whether or not the cats like string, apparently. This is not real data, but just to make up a data frame that we can manipulate throughout this. So the first cat, the calico cat, likes string, we'll have a 1. The black cat doesn't like string, and the tabby cat does like string. So it's 1, 0, 1, just indicating whether or not they like string. This is often like, in biology, this is often like survival, we can use a variable like this. So this is kind of like a binary, but just using numbers. So that's, again, it's going to go in as a numeric, but it is kind of like a yes or no type variable. Now, just before we move along, let's all just try and run this. And this is where I expect maybe a few error messages, so don't worry if you have one. Just try highlighting everything. And then you can either click run up here, and it should run in your console below. And if nothing else happens, that's good. That means it worked. If you get an error messages, maybe the parentheses are slightly off or something's going off. So just let me know if anyone's got error messages as we do this. But this data set, we're just going to build it ourselves right now because it's going to be, we're going to use it later. So if you can all try this one part, go for it. And if we have problems, I can try and paste my code in the chat. Just sometimes it copies weird into the chat, but I'll just pause for a sec. If everyone can let me know when you've got this running, let me know in the chat, say all good or something. Awesome, test is good. And feel free to add more variables. If you really like, you can add even more vectors to this. You don't have to be restricted to this example. You can add even more on. Just if you do customize it, note that some things later might not work perfectly, but we'll troubleshoot it as we go. So you can even try adding in your own vector, like, I don't know, you could add in like, likes catnip. And probably be like everyone likes catnip because cats love catnip, something like that. So you can make up your own, but just imagine this is like your data frame that you're loading in from an Excel file. It's going to look like this basically. We're going to have usually different rows, and each row is a different individual or a different sample or something like that. And then you'll have like your sample ID, you'll have your data value and other things associated with that data. So this is kind of how your data set already comes in anyway. This is just a really simple data set, so it's really small. Okay, it looks like we got 2 all goods. If everyone's okay with that, I'll just keep moving along. So just for people joining in, if you could try and make this data frame, I'll keep it on the screen, but just try and make this code just so you can follow along with this code. Now that we got it, we're good to go. So we can just look at the cats data set just by printing it. If we just run it by itself, it'll print out the values in the console. So this is what it looks like. We've got coat color, weight, and like string. So we've made a data set just that we're going to now use. And just like before, if you remember Lorenzo's talk, we can refer to specific column names by putting a $sign. So cats $sign coat will just return us the coat colors in order. Cats $sign weight will just return us the weight column in order. And then similarly for like string as well. We can also use that structure command from before, str on it, and you just see the different things inside of that. So we can see it's got coat color as a character string, weight as a numeric, and like string as a numeric. All right, so now we've got this kind of set up, this data frame. Let's just keep moving along. And the first thing we're going to try and do is we're going to add another column to this, but it's kind of coming from somewhere else. So we could add it up here, but let's imagine we just loaded in the data set from Excel and we want to add a column to it manually. So let's try making a column of age of cats. So we're going to make just a little object called age. It's going to be a vector. So it's just going to start with a C. we'll do 2, 3, and 5. So these are the cat's ages. And if we run this, again, it shouldn't give you any error messages or anything. It just should basically not print anything. It just means that it's assigned the value, but you didn't ask it to print the value, so it's not going to do anything else other than that. But we can see if we look in our environment tab, we've got a cats and we've got an age vector. So the cats thing is a data frame. We've got this little arrow here. We can click it on and off to see the columns inside. And we've got this age vector. Now, if we'd like to join them together now, which is a really common thing, if you've got like multiple data sources, you want to bind them together. We just need to think about how we're binding them. So we could bind them where the cats like, you just look at cats again, the cats data frame, we could put it so that like age is on the bottom of this table, but it wouldn't really make sense. So we've got like this 3-column thing and we're trying to put it on the bottom of this 3x3 table. It wouldn't really make sense. So what we're really trying to do is trying to stick it column to column. That's what we really want to do if you imagine it. So remember, cats is 3x3, and then this age thing is a new column, and we're kind of going to stick it in terms of columns together. So to do that, we're just going to use something called column bind or C bind. Everyone with me so far? So C bind, we're going to bind columns together. That's what C bind does. We can look it up in the help page as well if we forget. Combine our objects by rows or columns. So there's also one called R bind. As you can imagine, that binds rows together. But if we do C bind, cats and age, we just run this. And if I'm running it, if you don't see me press run, it's just because I'm using the shortcut Command Enter, just so everyone knows. I'm using Command Enter to run it really quickly, just automatically to that. So if you don't see me running it, you can try using Command or Control Enter, depending on if you have the macro windows. But now you can see if I do C bind on it, we've now got our original data set of cats, which is these 3 columns, plus we've got this age column now on it. So we've merged the 2 columns together. All right. How's everyone doing with that? Is everyone able to make that work so far? Cool. Awesome. Let me know as you're following along. And again, if you just joined in, try and just make this cats vector. It doesn't have to be perfect, or just make any, make this cats data frame, I should say. So remember, a data frame is just a number of vectors all stuck together. So we've got like a coat vector, a weight vector, and a like string vector, and they're comma separated between each one. So it's a comma, comma, and then the last one doesn't need a comma. And that's how we make the data frame for cats. It's just the data set that you're going to be using. So that's why it'd be good if you have it to follow along. It's really good if you try and follow along. All right, so let's try something else. Let's try now just doing the same thing. Let's use age, and we'll assign it instead of 3 values, 2, 3, 5, and we'll do, what do they put here? 12. So let's say we had an age column that didn't quite match the number of rows in our data set. So now I've changed age so that it's got 4 values. Instead of 3, it's got 4 values. So we'll add an extra value on to age. And now we'll try this exact same thing we did above. We'll do C bind again, and let's see what happens. Cats and age. So we'll just try running this now with a new age vector. And you can see you get an error from it. And this is where reading the error messages, a lot of times it's really unclear, but sometimes it's a little bit clear about what it's talking about. So it gives us this error. It says error in data frame. Arguments imply differing numbers of rows, 3 and 4. So what it means is that it's trying to combine cats, which has 3 rows, with age that has 4 rows. And R doesn't know how to do it if it's unequal sizes. So one's slightly longer than the other one. So when it's sticking the columns together, it's like, it doesn't like it at all. So this produces an error. So if you ever see this, and this is a common error that you do get when you're doing, when you're combining data frames together, just try and look at this, and this will actually give you a hint about which one is too long and which one's too short, the 3 and the 4. It's actually specific to cats and age, respectively. All right. Other operations we can do just to help with this is we can use n row is one that's good. N row stands for number of rows. We do number of rows on cats, for instance, gives us 3. And we do the same thing, number of rows on age, which is, oh, sorry, I can't actually do that. And the reason why this one doesn't work is because it is, does anyone want to guess why it doesn't work? Why does number of row on age not work, but it works on cats?
Because it's not a data frame?
Exactly. Yeah, exactly. It's not a data frame. And it's not, so it's not like, it's not built the same way. It's actually just a vector. So if we do that is or type of, I think we used last time on age, we'll see that it's, oh, actually, no, sorry, that's not right. Use is vector, and it'll return true. And if we did like is data frame, same thing. On age, it says false. So it's, yeah, it's not a data frame. So for vectors, to measure the actual number of rows essentially in it, we have to use length instead. So just one little difference that it often leads to like confusing errors, but if we use length on age, it'll give us the length of that. So just remember, vector again, it's like one column of data, whereas a data frame is many columns glued together. So it's more like a kind of a two-dimensional thing when you're talking about a data frame. So number of rows makes sense for cats. It's got 3 rows. We can also look at number of columns, same thing, but just write n col, and that will give the number of columns. Number of columns, and this is number of rows. And this is the length of the age vector. All right, so subtle differences there, but just remember that when we're looking with vectors and working with data frames, it'll produce slightly different things. And if you get null out of ever like a number column or number row, like we did for age, it's probably because it's just a vector, not because it doesn't have any rows. It does have kind of rows in a way, but it's just a vector, so it's not really arranged into rows and columns. It's just kind of like a line, just like a one-dimensional thing. So that's why it's giving us null there. Hopefully that makes sense. Let me know if anyone's got any questions or comments about this. Just throw it in the chat. Or if I'm going too fast, we can slow it down. Or if you want me to go back to the data frame, let me know as well. I can throw that in. We're actually doing pretty good though. All right, so we added a column to it, but sometimes we get an extra individual. So what if we had another cat and we wanted to add this cat to our data set that we forgot to include it before. So we just want to add it really simply to our data set. So if we had a new row we wanted to add, one way we could do it is we could go new row, new row, and we're going to assign a value of data.frame. And here, we're just going to kind of fill it, the data frame with, basically we need it to have the exact same column names as before. So whenever we're merging things together, it's only going to work, I think, if we have column names. So if we tried to do it without the column names, I'll just use the values they have here. So maybe it's, what color cat do we want? Speckled. I don't know colors of cats very well, but it's speckled coat. Its weight is 3.3. It's got a value of 1 for it likes string, and yeah, and I think that's it for what we have so far. So we've got 3 values in cats. Again, we need to fill in a coat, a weight, and a like string, and this is like a separate row that we're going to add to the bottom of our current data set. So we can try doing it like this. I don't think it's going to work though, so let's just see what happens. If it works, then I'll eat my words. But the way we are going to combine them together, can anyone guess? Before we use cbind, now we're just going to use rbind, because we're now talking about rows. So we want to add on rows to the bottom of our data set, basically an extra row for one more cat. So instead of cbind, like before, we're going to use, rbind, rowbind. And we're going to use rowbind again on cats with this new row of data. So new row. And let's see if this works. I'm not sure if it's going to work. Yes, so it gives me an error. It says the names don't match. So to fix this, it's really simple. We just actually have to add in names. So if we look at our new row data set, for instance, it's currently trying to name the rows, the column names for us. It's calling it x.speckled, x3.3, and x1, which is not very good. We don't really want that. So we can assign these names ourselves just by writing again coat equals speckled. We can write weight equals 3.3. And we can write, what was the last one? Likes string with an underscore. We could also just check the names as well from before if we wanted to. So we could even go names of the cats data set would just give us a list of the names. So coat, weight, and like string. Then we could enter them here. Coat equals, weight equals, and like string equals. Now that we've changed this, this should work. So now this actually should hopefully work. So we'll try running this new row line. So we've made a new row of our data set. If we look at it, it's got the exact same row names as cats. did before. So now we should be able to combine it together. Now we've got the same row names in theory. I hope it, sometimes I get mistakes anyway. Okay, looks like we're good. We've got when we r-bind this, we've got the cats to the new column, or sorry, to the new row of a new cat. So we've added this speckled cat in here with the weight of 3.3, and it also likes string. We've added it to our data set. But the thing we're doing right now is we're actually just printing it. We're not actually saving anything when we do this. So that's gonna be an issue. We haven't actually saved this as anything. We're actually just printing it out. So if we really wanted to save it as our new data set, we would probably want to do like cats2, and we'll assign the value of this. So we're gonna put into cats2, we're gonna put in this r-bind thing. We're combining the rows together, and we're gonna put it into a new object called cats2. This is our new data frame of cats. And if we do this, now we've got it saved finally somewhere. Cats2, if we look at it, it's got that extra cat on it as well. How's everyone for this so far? That was pretty much the first little bit of this. I think now we're just gonna move on to a few more things. I think we should, yeah. Maybe we'll add, does anyone work with factors a lot, or does anyone want to learn about factors? I was thinking about skipping this section, but we can talk about factors a bit if anyone's interested. I don't use factors too much, but they are really helpful for plotting stuff eventually. Basically what a factor is basically you can change any character string variable to a factor just by writing something like this. So if let's say we want to make a new column in cats2 called coat as a factor, coat factor or something like that. So we're gonna make a new, so this, if you look at this doesn't exist yet, but we're gonna assign it a value of basically the same length of the rows, so that it's now a new column in our data frame, in cats2's data frame. So to do this, we could write something like factor onto cats2 $coat. So all this is doing is it's factorizing this little part here, which is cat's coat. So that right now, if you look at this, and maybe we write is on this, we could see that it is a vector of characters, is what that means. Just if you wanted to explore what it is. But when we factor it, we're going to change it to a new class called factor, which is something we didn't touch on too much yesterday, but basically just means that we've got now an order to these different character strings that's kind of prearranged. So if I do this now, and instead I look at this, I'm just going to copy this and go is on this. I don't want to save this. I'm just going to write on the bottom. We'll look at this is now this column, coat factor is now a factor. It's also kind of an integer, so it's a bit weird, but it's actually become an integer. We'll talk about that in just a sec. And if we look at the actual values in this new thing, we see basically the same thing as before. So let's see, before we had the coat variable is just like characters, so you see there in quotations. But now we've changed it so that coat factor is actually, it's printing them out just like before, but it also has these different levels. So this implies an order to it. So this is where it would plot it in this order, and we can actually rearrange these levels to have different effects. So for instance, it's just arranged it alphabetically. So it's got black first, then calico, then speckled, then tabby. I think Lorenzo talked about how to reorder things. So I'm not going to talk about it too much here. There's a lot of help on how to re-level factors, it's called. So just know that this is makes a column of coat as a factor. And just remember that factors have an order to the values. These are called the levels. All right, so they've got some kind of order implicit in them, and that's why it says levels here. Now, here's the really interesting thing. Let's say we wanted to get this back to a character string. How would we do this? Let's say we wanted to convert, let's say our data set came as a factor, or we made it a factor, we didn't want to. Maybe we overrided something, we didn't mean to make it a factor. How would we go back to a character string? Does anyone remember from last time? There's any ideas? I'll give you a hint in just a sec, but I just want to pause. If we wanted to convert this coat factor back to a character vector instead of a factor vector, what would be the command we could use to do this? I'm thinking as and then something. Oh, it's going to say it there. So we can coerce something into another type. One, if it works. So you can't coerce, for instance, like a character string into a numeric because it doesn't know how to convert letters to numbers. So it can't do that, but it can convert it into a character string just by going as character. And if we just copy this and just paste it in here so I don't have to write it again, this is going to revert it back to a character string. So we could resave this as a new character again, or sorry, a new column again if we like, or something like that. But that's how we can get it back, is as character. We can get it back to a character string. All right. So just like we can convert coat color to a factor, one thing that we can also do, this is something that is probably bad, but we could also convert cat's weight into a factor. So let's say we did this. Let's say we made a boo-boo. we accidentally converted our weight as a factor. So weight, as you can imagine, weight is a number, like 3.3, that's a number. We don't want it to be a factor. Factors like categories. So it doesn't really work for a weight. And if we had like many values, we're gonna end up with many factors, and they're all gonna have different levels. It's gonna be really weird. So let's say we made a mistake. Let's say we accidentally converted weight to a factor. So you feel free to run this or don't run this, because this is going to mess up our data frame. So we will have to fix it. But if we run this and now we look at weight, it's now converted. So it's like numbers, but it's got these levels too. It's really weird. So this will not work. We can no longer add numbers together. For instance, if we went like, if we just wanted the first value, we could write, I'll show you this in just a sec, but if we just wanted the first value of this 2.1, we could write this 1. And if we want, for instance, the first value plus the second value, we could write something like this, but this is not going to work because it's a factor now. So we've actually messed it up so bad that we can't actually use it anymore as like a number. It's not adding the numbers together anymore. It's considering them factors, which are kind of like character strings. So this is really bad. So this produces an error. Don't worry about copying this part. This is just to show you that it's no longer a numeric. So what are we going to do? How the heck do we get it back to a number if it's now a factor? Well, one thing we might try, and you might be tempted to do, is as numeric. We could try doing this on this cat's $2 weight. I'll show you what happens. If we just do this and we're going to print out the results instead of saving them right now, it prints out weird numbers. So before, if you remember, the numbers were like 3.3, 1.2, something like that. It's now just 1423. Like what? What has happened? So this is these are numbers, but not the right numbers. Sorry if my laundry machine is really annoying. I hope it can't be heard too much. So there's a little extra step that we have to do for this. So what's happening here is it's basically assigned these values in terms of their number order. So the levels are 2.1 is the first value. That's this first value. 3.2 is the second value, but that's actually in the third place. 3.3 is the third value, and that's in the fourth place. And 5 is the fourth value, and that's in the second place. And it's actually converted these into basically their respective positions. So it's like 1, 4, 2, 3 was the order of increasing numbers is what it's done. So it's really messed it up. It's really like, we can't use this right now. So the step that we really need to do to fix this is we need to go as character on this. So the first thing we do is we're going to convert it to a character. If you look at this, it's going to make it so it's just in quotations. And then around this, we add now as numeric. And this will finally get us back to numbers. So this is what we have to do to fix it. So if you see now, it's finally produced them back as numbers. And lastly, we can save it back into cats2 weight. So we can try running this. So it's a bit weird. If you didn't do this first step, you don't have to worry about doing all this stuff, but just know that if you convert something to a factor, it's a little bit trickier to get it backwards. So you have to do as character and then as numeric to get it back to a number. So now if we do this and we look at our column, we've got now numbers again. So we're good, we're back to normal. But that's just one way that we can really mess ourselves up if something goes to a factor. So it's one of those weird tricks that if you have something as a factor and you want it back to a number, you have to use as character, then as numeric within that. Bit weird, but anyway, that's just if we screw up. And now you can see if we run this, we add the first value plus the second value. It actually does do the first value plus the second value. 2.1 plus 5 gives us 7.1. All right, so we're good on that. So now we're going to move on. Does anyone have any questions about what I've kind of talked about so far, or things to talk about again? Let me know in the chat if you're good. So now we're going to talk about subsetting after this, which is the biggest kind of part of this. So we've done a bunch of like adding rows and columns on. We've changed things to factors, which are a bit weird. Now we're going to talk about subsetting data frames, which is probably the most important action that we do every day. This is where, if you've got an outlier, if you've got some weird value, we can specifically work with that one weird value. So it's all about looking at your data frame and specifically taking out certain values. So one way we can look at our data frame without taking out specific values is if you just write view around it. So if you view cats and you run this, it will open up the data frame in a new window. You can actually look at the values and you can be like, oh, the black cat actually did like string, my bad. I needed to change that or something like that. So we can identify outliers just by looking at it. But when we have a really big data frame, for instance, genomic data is really bad for this. It's really not going to be efficient to look through the whole data frame and find that one value that's bad. So we're going to use subsetting tricks to get at this and get at this a different way. So just imagine that this data set isn't just 4 rows long. Imagine it's really long. We don't want to spend the time looking through pages and pages of data. We want to just do it in a really efficient way. And so R is really powerful for this. We can do a lot with subsetting. So the first thing we can do is, let's just say we did find that row that we don't like, or that row that's an outlier. Let's say that it was, let's say it was our first calico cat. That was actually not a true cat. I don't know why. Maybe it was a bad value, or maybe it was a duplicate value, but we actually didn't mean to include that calico cat. So how do we get rid of this? Well, we could make basically a subsetting operation on it. So every subsetting operation starts with your data frame name. We start with, if it's a data frame, we should say it first. This is what we're going to do. We start with our data frame name. Then we're going to add in square brackets the row index by column index. This is kind of how we pick certain values out. So what I mean by this is, and it's going to be comma separated between this. So the row index is basically which row do we want? Is it the first, second, third, or fourth row? The column index is which column we want. Is it the first column, second column, third column, fourth column, whatever. But we only have 3 columns, or we do have 4 columns actually. So we can pick certain columns and rows out of this using this. So for instance, let's say I just wanted the weight values. How would you write this? You can probably imagine we could cats2 open up this subset operation, these square brackets. We can put spaces in, it doesn't matter, spaces can be added. We just need to have a comma in there because we're going to have row and then column. And it's always row by column. It's like a thing about mathematics. They always just do it by default. It's always row, then column. So if you remember one thing, just remember row by column, not column by row by column always. So the first one is row. And let's say we just wanted the weight value. So if we want, we just want to get this one column out, the weight column. How do we get just the weight column out? Well, the row index, we're going to leave it blank. If we leave it blank, it means take everything that's there. Just leave it as is, but take everything that's there. So we're going to leave the row index blank. The column index now, which column is the weight vector in? That's right, it's 2. So we're going to add in a 2 there. And that's literally it. So we just run that. And now we've got the weights coming out. So that's weight is in column 2, we know. If we couldn't remember what the column number was, we could view the data set like we did before, or we could also look at up here and look at cats2 with this little arrow. We can drop it down. We can see weight is the second column. Or another way is just writing names again, names on cats2. Many ways of doing it, but we can see that weight is the second thing that pops up. So that's the second thing we want. If there's also actually another way to do this, we can also write cats2 nothing, and then in quotations, we can actually write weight. Because it's a data frame and it's named, we can actually write the column name in there, and we'll also do the same thing. So 2 different ways of doing the same thing. Pick your way. And one last way you can also do is cats2 $weight. Just kind of 3 different ways of subsetting, specifically for the columns. And columns are a little bit easier to pick out compared to rows. So just know that this is like 3 different ways of extracting what we want. I tend to use this $weight because it's just a little bit less text and it's easier to read and understand, whereas I don't always remember what column weight is, but you can do it either way. It doesn't matter which way. All right, so that's if we want the weight column. Let's say if we want to extract, let's say the tabby cat row. So we want to specifically get one single cat out of this. How do you think we should do this? So if we're doing a subset, we always start with the data frame name, cats2, and now we're going to add in a row index and a column index. So if we wanted just the tabby cat row, what's one way you could extract that using this subset operation? If we wanted the tabby cat row. I want to say, so I understand why you thought that, but it's actually, it's a bit of a trick question, and I probably shouldn't have showed you how to do this right away. That actually won't work, sadly, the first thing, the tabby thing. I'll show you why. The problem is that we don't actually have in this data frame, if we look at it, these are actually the row names. And the row names are 1, 2, 3, and 4. They aren't actually named coat. So if we wanted it to do it that way, we wouldn't be able to do it this way. So if I tried doing this, I think it would give us NAs all around. So it doesn't quite work, but you're on to the right track. We can actually do that in just a second. I'll show you how to do that. But just using numbers to keep it extremely simple at first, we'll just add in a 3 as Kath suggests. So we're going to add in the third row, which is where the tabby cat is. So we want the third row for tabby. So we can do this and we'll get the tabby cat out. Now, another way to do it kind of like this, because we don't have any row names, it's tricky. One thing we could do is we could maybe assign row names. We could write row names of cats2, and we assign them to cats2 $coat. If we did this beforehand, then we could do it the way that Tess suggests. So if we added in row names, and then we look at our data set, it's now got the row names specified. So we can set the row names by going row names of cat2, and then I'm assigning them values from that. And now we could write tabby, and it would work. There we go, we get the tabby out if we do this row names trick. Another way, so you don't have to assign row names, because I actually find that I don't really use row names very often, because usually your data set's so massive that it's just like, it's already in like the columns. Usually it's just easy to refer to the columns. And some operations actually get rid of row names a lot. So if you, for instance, if you save CSV files, often it won't save the row names. So that would be a really big issue that will delete the row names. So usually we work outside of row names just with column names mainly. So unfortunately, this is a way you could do it. I just add this down here maybe. We could do it this way where we assign row names, but let's say we didn't assign row names. So imagine I didn't do the row names thing before. One way we could do it, the way Tess suggests, is going cats2, and we can actually use logical statements. So I'm jumping ahead a little bit here, but we can use logical statements to get at this. So if we, for instance, write cats2 $coat, and we want the coat to be equal to tabby. So this is really weird looking, but this is using logical statements. I'll show you what that means. So if we just look at the interior part first, I'll just paste this up here maybe. Cats2 $coat, that's giving us a vector of the whole data set just for coat color. The next thing is we're saying, is it equal to tabby? So it's giving us, this is going to give us false, false, true, false, because only the third cat is named tabby, or is a coat color of tabby. So we're specifically now making like a logical vector. So this is make a logical vector, and using logical statements to subset is what we're now doing. So this is how you kind of want to do it if you're not assigning row names. So we could do it like this. We figure out a vector that gives us falses and trues. And basically when we put in the falses and trues, it's only going to give us wherever the row index is true. So just like we can write row 1, we can also write row if it's true or not, this vector. So now what it's doing, quite amazingly, is it's going through and it's looking for where the coat color is equal to tabby. And where it's true, it's now giving us tabby. And this is really useful if you've got like many, if you imagine you have many cats and many of them are going to be tabby cats. There's multiple individuals with tabby cats. So this is going to give us every individual that is a tabby cat in there. So that's really nice that it does it for us. Whereas this row names thing actually would give us a little bit of problems with that. So this is actually the better way. This is the best way. I was just skipping it. I'm skipping a little bit ahead. So we're going to practice this a little bit, making these logical vectors, but this is the best way you can kind of find values. Is basically you figure out where in the rows is the tabby cats, and then we say, okay, just give me the data frame where the rows are equal to tabby cats, and any column as well. So I'm leaving column blank, but remember I could also write coat or something like that, and then now I'm getting the tabby cats and I'm getting the coat color, so it's just going to give me tabby. So you can really go crazy with this subsetting, and we can do it any which way. Is that, hopefully, is that a little bit clear to everyone? So one thing we're going to do now is, let's pretend we've made a big mistake in terms of the values. So looking at our cats data set, let's say that this black cat was actually not nearly 5. It was actually 0.5 or something like that. So we made a mistake on the 5. Maybe it was doubled somehow. So we meant to actually put it as 2.5, but we put it as 5. Now, how do we fix this if we want to assign this specific value of a value of 5? Well, the first thing we can do is we can make a subset to just return this one value. So if you had to return this one value from the data set, the cats2 data set, what would you write to get this one single value from it? What do you think? Remember, it's row by column. So we need to think about maybe the row number and the column number to get it out. If you want to be extra fancy, you could do it the crazy logical way, but you don't have to do it that way. So if we wanted the specific value out, we wanted to just return 5 basically from the data set. We want cats2, we want to specifically target this 1 5 in the data set. How would we subset it to get that? It's a bit tricky. Yeah, a lot of good answers here. Yeah, these would all work. So we start off with the data frame name as always, cats2, add a subset where we write 2 and 2. If we run this, we can now see, and I'm just going to make a comment here, the second cat's weight's wrong. This will return us the value of 5. So we wanted to reassign it to a new value. All we have to do is actually just write assign it the value and then enter the new value. So 2.5, we'll reassign it a value of 2.5. So now we've just fixed our outlier in the data set, knowing where it is. So we can do this. And now if we run this again, we'll see that cats2 at 2 and 2 is 2.5. We look at the data set, it should update to, yeah, so we've got 2.5 there now. So it's actually already updating cats2 for us in this view window. So now we're good. We fixed the black cat's weight. It was double than what it was. So now we're assigning a new value here. Subset, then assign that weight, that cat's weight, a new value of 2.5. That's what we've done here. So this is a really powerful way that we can look for things. Let's say that we actually, we actually made a big mistake and we actually didn't record we thought we had recorded this weight for this cat, but let's say, actually, let's do a new cat. Let's say that the 4th cat, we actually didn't record whether or not it likes string. So if we wanted to change whether or not, I guess the question I'm asking you is, we actually didn't get or obtain whether or not the 4th cat likes string. So we need to assign it a value of NA. We need to reassign it a value of NA to fix it. So we need to fix the data set at a certain exact point. So how would we modify this to get at that 4th cat, whether or not it likes string? What do you think? So we need to assign it a value of NA. So the first thing we can think about is this is going to be NA here. We're just going to write NA. It's a special value in R. It returns a little bit differently. And we want to get like string for the 4th cat, the speckled cat. How would we get at that? We want to assign this value NA because we forgot to measure it in our data set, or maybe it was just a nonsensical value that we don't know the actual value for. So imagine you're measuring a bunch of things and you've got like this really crazy outlier that can't actually exist. You want to assign the value of NA to basically make sure that it's not used as it is. You want to get rid of that value. So you could load the data set back into Excel, you could delete it, and then you could go back. But often we'll find that this is actually easier. If we practice this, we can do it really easily in R, and we can do it for many, many values all at once if we want. So does anyone have an idea? What would be the row index? Oh yeah, perfect, we got it. Thanks, Sandra. So it would be 4 for the 4th cat, and then 3, because that's the value, that's going to be specifically this value here. It's the 4th row down and the 3rd column. So this is our columns: coat, weight, and like string. Ignore this one. This is just the row names. So this is the 3rd column and 4th row. So we write 4 by 3 or 4 then 3, and we assign a value of NA. And now if we look at the data frame, you can see it's now assigned NA. So it's not going to use that value anymore. So we've gotten rid of that outlier that was going to cause us problems, or that value that we didn't actually know in our data set. So this is really kind of useful if you just have like 1 or 2 values that you need to fix really quickly. Once you load the data set in, you could just quickly modify them to NA, and now we're good. All right, I'm definitely jumping around to this tutorial a lot. Maybe we'll jump. Cool, we're actually getting close to the end, I think. There's just a few more tips and tricks that we can talk about. So what if we wanted to, so now one thing that we can use is actually this useful function called NA Omit on cats2. What it will do is it actually remove any of the rows that have an NA value in them. So if we look at this, it'll actually just get rid of that 4th cat for us. This is a useful function for getting rid of incomplete data. But remember, if you have any NAs anywhere, it will give you, it will get rid of them. So this is one way you can get rid of specific values that have NAs. So if we run just cats, it had 4, but the like string was NA. So NA Omit on it gets rid of it specifically. Another thing we can do is, let's say that we had like NAs elsewhere, like in coat color or something, or in terms of weight, but we didn't want to subset just on the NAs and weight. We just wanted to specifically subset based on NAs and like string. We could write cats2, and we'd write NA Omit. I think this is going to work. Let's hope this works. Of cats2. I've probably done something, a bad idea here. So this first part is going to give us certain values. No, this isn't actually going to work. Okay, I've got a different way of doing it. So let's say we wanted to specifically get rid of NAs in a certain column. We can write logical vectors. So one way we can get logical vectors is just using is. So is NA is a really common one I use almost every day, because we can look at whether or not there's NAs in it. But unfortunately, it doesn't really work, I think. Well, it kind of works with data frames, but it's going to give us a lot more columns than we want. So we specifically just wanted is NA for the like string. We could write is NA on like string. This is going to give us false, 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 true. So now if we wanted to just get the value that is NA, so imagine we loaded in our data set, but there's one value that was NA and we couldn't find it. It's a really long data set. This is the perfect thing we can do. We can now subset it using this logical. So this is going to just give us logical of if the column is NA. Now if we take this and we paste it in, should it go in the rows or the column index? If I'm going to paste this in, this logical vector. So what is it doing? Is it rows or column? Any guess? It's 50-50 anyway, but. So it's actually, because we've already subset it based on this column, it's going to tell us based on the row. That's the only thing that's left is the rows, because we've already just looking at one column. It's telling us which one is NA. And now we're going to paste it as the row index. I've just added spaces. You don't need to have spaces, but you can add spaces if you like for readability. So what this is doing again is it's giving us true or false if it is NA, if it's a value of NA. And then lastly, it's now we're telling it to subset the cats2 data set based on if the row is true for if it's NA. So we're kind of combining everything together to get out just the values that have an NA for like string. So this is a really good, I use this almost every day for data exploration. So there's one piece of code that I think is really useful. It's this NA stuff. We can use isNA to find the specific values that are missing from our data set using this isNA. So it's really useful for subsetting it like that. Now, what if we wanted the opposite of this? What if we wanted actually only the ones that aren't NAs? We wanted just the ones that aren't NAs. Well, a really easy way you can flip logicals is just click at the start of it and write an exclamation mark. What this does is it says the exclamation mark in terms of logicals means the opposite of that. So it's like, if it is an A, it's now going to, and it was true, false before, now it's going to be, if it isn't an NA. So it's writing true, true, false, whereas before it was false, 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 true. Now it's true, 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 false. So it's just flipping it. So we can write exclamation mark reverses logicals, makes true, false, true to false, and false to true. So now we can specifically use this, and this will again get rid of only where it's NA, it'll get rid of any NAs in our data set. So this exclamation mark is an A. I use it so much because often we have NAs in our data set. This just gets rid of the ones where we don't want it. It cleans it up for us, and then we're hunky-dory. All right, we're running a little bit of time. A few other tricks that you can do. So let's say we have a really large value in our data set. So for instance, we only want cats that are smaller than 3. So the weight is smaller than 3. So let's say we wanted just cats that are where the weight is smaller than 3. And as you imagine, I'm making this up, but it could be, it could be something that you're doing where you want specifically values that are really large or really small. So we can look at maybe we just want to look at cats, let's say larger than a value of 3. Cats with weight larger than 3. How could we write a logical statement to subset the data in a really smart way? So we just get cats that are larger, that have a weight larger than 3. Can anyone think of a way? One thing we can use that will help is this greater than command. So remember, greater than or less than, we can use this greater than arrow. For instance, if I write like 4 is greater than 2, it'll return true. So it's going to make us a logical from this, and we can actually use this as our logical. So yes, perfect. Yes, thank you. I'm really just going to copy your code. We're running out of time. So we can write, cats 2 $weight, and we can say greater than 3. We want just the weights where it's greater than 3. And that's what this logical will do. It says, okay, first cat, nope, that's not true. Second cat, nope, not true. Third cat, yes, it is greater than 3. And fourth cat, yes, greater than 3. So now that we've got this logical vector, all we have to do is copy it and paste it as our row index. And now you'll see we're just returning cats that are greater than 3. So this is really useful again if you've got an outlier that's like really big and you know it's over 10 and you need to find in your massive data set, but you don't want to like look through the whole data set. So you're just going to look at it like this. You can just subset your data set where you've got your data set name, a logical vector of if one of the columns is greater than a value, and then you've got a column index in there. Another 2 more things before we finish off subsetting data frames. If we write cats, if we want to subset, for instance, 2 different values from there, we couldn't really write, like let's say we want the first and the third row. So as you can imagine, we've already got a comma here. If we want the first and the third row, we can't actually write 1, 3 because now we've got 2 different, it actually does return something, but it's not really what we want. So if we wanted specifically cats 1 and 3, what we would have to write is make a vector of this. C for a vector, add cats 1 to 3. Boom, we've got cats 1 and 3 based on this row index of 1 and 3. If we didn't want cats 1 and 3, we can also write it as minus C1 and 3. So this is where if we write minus C1 and 3, it's giving us -1 and -3. What negatives do in subsetting is it gets rid of those values. So here we've got, specifically we're getting, oh, sorry, it's cats 2, my bad. Not cats, we're using cats 2 right now. If we didn't want cats 1 and 3, so this is getting rid of cats 1 and 3. And this one is extracting or returning cats 1 and 3. So we can pick out specific values using this. And then lastly, one cool thing we do, let's say we wanted to, this is probably the hardest thing we'll do today, so I'll just end on this. Let's say we wanted to, final problem is, let's say we wanted all the cats that are calico or black. So there's 2 ways we can do this. if we wanted specifically cats that we either calico or black, we need to write basically a logical statement that's going to give us something. So for instance, we would want maybe cats2 $ coat equal to calico, like we did before for tabby. So this would give us trues and falses. But we also want if it's equal to black at the same time. So there's different values. So we want basically the trues from the first one and the trues from the second one all together. So the way we can write this as a logical statement is we just put it on the same line and add a bar. This bar means or. So you can write and, like an ampersand. That's another one we can do. If we wanted calico and black at the same time, which is impossible, we could run this. But it would all be false because you can't have both codes at the same time. But if we wanted just, if it is calico or, or with the bar, it is black, we can run a logical like this. This would give us just if it's calico or black. So this is return if coat is calico or black. This is another cool logical that we can use. And let's just plop this into a subset command. You'll see what I mean. Cats2 subset based on a row. And we'll put in the row as if it's calico or black. And there we go, we get calico or black from that. So that's another cool way we can do it. And even sneakier way, if you've got a long list of cat colors that you want to look through, let's say we want to search, we can make like a vector of like coat colors. So search coats, we'll make a new vector of calico or black. This is the most advanced thing I'll show you today. There's a really cool type of logical called in. And what it does is it basically looks for values in a vector. So if we have like, for instance, 1, 2, 3, 4 in 1, it will find the values that are apparent in this one vector. In this case, it's a value of 1, but we can even do it for multiple, 1 and 2, for instance. This will give us trues wherever in this original vector, if they appear in this. So it's a way of kind of searching many different things at once, is this in way. So another way we could do this part we did up here is making a logical like this. So we go cats $coat, oh sorry, cats2 $coat in, and now we're going to use our search coats vector we made up here. So we can in search coats. So we're trying to find the coat colors that are in this vector of the coat colors we want back. And if we do this, we'll get trues and falses again. And this will actually be perfect for us. This will give us the logical that will give us exactly what we want. Cats2. I'm sorry, guys, I'm going way through this, but it's just because we're out of time. Way quickly through this. So now the way what we've done here, if I just put it all together, is we made basically a vector of the coats we want to return. So we could change this calico to tabby or anything else. We made basically like a search vector. That's the vector we're searching through. Then we say, okay, through this column, we're looking for any values where it's in this search vector. So this in command is like, we're looking for any of the values in this search vector, and it could be any of them. So this is really useful if you've got like a ton of things, because it's really hard to write like calico or black or tabby or orange or red, or, you know, and keeps going on and on. It makes a really long thing of code. So if we have many, many search terms, we can do it this way, and it's really efficient that way. So we've got the search code. It's just, if it's calico or black, we want it to return it. Then this gives us a logical of if it's in that. So this is our search vector, I call it. This is whether coat is in the search vector. Cats coat matches, I should say, matches any value in the search vector. And then lastly, we're doing the subset. And lastly, if we wanted to say this is a new data frame, we could do like cats3 or something. And we could assign this a whole new data frame. Now we've got cats3 nailed down, and we've got something there. All right, so that was a whirlwind through data frames. I didn't quite get through as much as I wanted to because there's extra things on lists and stuff. So just know that lists last time are a little bit weird. They're kind of like data frames, but instead to search a list, you have to use double rectangles, or like double rectangles. This is for lists. So if we had like a my list, we have to search specifically through certain values. So lists are a bit weird, just know. So if I wanted to do like my list and make it a list, that's how we make a list. And then we write like value of 1, Second thing is a random vector, and then we can also even add in a data frame like cats in there. And this is going to save it. Basically, lists are weird. Remember, lists are like the most flexible thing you can do. It's giving us basically, we've got an atomic vector, like a one value, we've got a vector of numbers, and then we've got a data frame, and it's all combined together with the list. So this is a really common output for some really complicated functions. They often like return list objects because they can return a bunch of different things like matrices, anything else all at once, and just basically makes a list of things. If we wanted specific things in this, like let's say we want to get out the cats, which is the third thing, we would just write a 3 because it's the third item in the list. It's the third item is this whole data frame. And if we do this, we'll get out the cats. But you have to have this double rectangle. So it's a bit weird. Lists are a bit odd. So just know that lists are extra weird. I didn't really get to cover them much. But anyway, I think that's all I've got time for today because we're already out of time. Does anyone have any last questions about anything? I know I went through it quite quick at the end just because we ran out of lots of things. But hopefully gain some insights into kind of how you start about subsetting. And as you do it more and more, you get really good at thinking about logical statements that will give you exactly what you want out of it and save you a ton of time in the end rather than doing it in Excel. Especially for really large data sets, it's super powerful to search through really quickly. Any questions? Everyone's just confused.
This ties in nicely too. And our next session is on for loops. So Natalia will be running that next Monday. And then you can make for loops in case you want to search for multiple things. So, if, for all of those cats, I want you to do this.
Yes, so repeating operations that you can go through. So what if you wanted to sum weights with like string for the first row, then the second row, then the third row? There's a way of doing that with a for loop to do like a bunch of operations to it. Yeah, it should be good. Anyway.
Hey, Kevin.
Yeah.
How often do you use this? Do you do everything this way? You don't do it in Excel and then go through?
No, I just do it all over.
But in Excel, so if you do all this, your Excel document is still as it is, right? So if you find an error, would you not just fix it in Excel so that you know if you use your data set later on that error is fixed?
Yeah, I think it's up to you. Sometimes, like when I get data sets from other people, I just always keep them the same, and it's like don't touch them. But so then I might modify it, and then I'll save another file as like I call it data process. So I've done all the error checking and fixed everything as factors and whatnot. If I'm using factors, and so that's what I'll usually do. So it's good for that. So yeah, there are some times that you have to do it, but a lot of times it comes in handy because you've got like values like that are like quote like character strings, but they're actually supposed to be NA values. So if you didn't, like for instance, in Mia's data set that I have, it's a lot of like did not find or DNFs, like quote in quotations, and we can't use those because we didn't find them again. So basically just recording, we didn't see them, but I have to basically get rid of them. So the first thing I do is I set them as NAs so that I can work with them as NAs, and they're really deleted. Because if you don't do that, then if you go into like plotting functions later on, it'll give you like really weird error messages if you don't set them.
Okay.
Yeah. Is that a tabby cat there? Or is it?
Yeah, he has joined us for this entire session.
Perfect.
Thought you were talking about cats. So.
Oh.
Yeah. Okay. Cool. Thank you.
Anyways.
That was good.
Cool. Hopefully not super confusing. There's a lot here, so don't worry. Subsetting takes forever to get your mind around. But the more you do it, the better you get at it. And we'll show you an easier way of doing it when we get to dplyr as well anyway. So there's an even simpler way of doing this. This is kind of like the basic way, but when we get to the tidyverse, it gets even easier. So don't fret if it's super confusing. In the new year, we'll cover more of the tidyverse and plotting and things like that, where we really get kind of creative with this stuff. Anyway, thanks for everyone for listening. See you all next week.
Thank you. See ya.
Kevin.
See ya.